root graph. A square root graph has a formula y equals to a, and the square root we have a linear under that and plus any k values. Okay, so that is a square root. That's a square root. So cube root is very, very, very similar, 99% similar. We just add a 3 on top of that. That's a cube root. Okay, so it's still you got a cube root, a linear plus a k value. That's a cube root. Let's have a think. What's the difference between a square root and a cube root? If you have a cube root x, the graph looks like this. Okay, on the right hand side, a cube root x. We have first quadrant and third quadrant, and we have a point here, 0, 0. Well, this is an increasing graph. Okay, it's all the way increasing, but it's not really increased smoothly. It's not like increasing like this. So there's a turning bit here. If you make this larger, it like shows a point of inflection here. Okay, it's just turn a little bit. It's a little bit different from the cubic. If you remember cubic, we can have a cubic shape like this. Okay, that's a cubic shape. This is just totally the other way, like turn 90 degrees. Okay, so it's like a kind of vertical here, so it's a turning. So you need to show this turning. Okay, this point is a key feature. So we said this graph got a point of inflection at 0, 0. It got a point of inflection at 0, 0. So that's the key feature. Go back to the first 3 graphs we have learned so far. Hyperbola got 2 asymptotes, truncus got 2 asymptotes, and square root got an endpoint, which is the 0, like the endpoint. And now cube root will have point of inflections. Okay, cubic graphs will have point of inflection. So that, well, for that graph is 0, 0. Also, the domain is a little bit different from the square root. Well, if I can show this square root graph here, let me show you the square root and make it larger. If I can show you the square root graph, that will be the square root graph, okay, square root x. And the red one will be the cube root x. Okay, the red one will be the cube root x. So the difference is not only like the shape is pretty much the same in the first quadrant, but like in the third quadrant, we have graph for cube root as well. Okay, we have graph for cube root as well, because the domain is not restricted for cube root. If you can think about the implied domain, there's no restrictions for odd power graph, odd root graph. Okay, so we only have root with an even number. Then we have restrictions. The inside must be greater or equals to 0. But there's no restrictions for cube root. Okay, for odd power there. So therefore, we'll have negative infinity to positive infinity, which is r. Okay, everything is possible to take. Cube root -8, that will be -2. So it's possible to take negative numbers. But also you have a negative y value. Therefore, it's in the first quadrant and in the third quadrant. Okay, in the first quadrant and in the third quadrant. So, therefore, we can have a look, a general case. Well, the domain and range, okay, just remember general rule. If in the question, the domain is not restricted on purpose, otherwise, if it's implied domain, the domain and range is always R and R, okay, for cube root. There's no restrictions for the domain, there's no restrictions for the range. Unless the question say, for example, your x must be in between that. Unless the question restricted by itself. Otherwise, if just give you a cube root function, ask you about the domain and range, is always R and R. A natural cube root graph is always with domain and range R and R. Okay, that's the cube root. Let's have a look at a more general case. Okay, a more general case. Just a little bit small test. What is the first thing we need to find for a square root function? Endpoint. Okay, endpoint. So then the first thing we'll find for this one will be the point of inflection. The point of inflection is like the middle part. How to find that is exactly the same as how you find the square root. Okay, do you remember how to find the square root? We make the linear equals to 0, and the y, that will give me an x value, and then the y value is just k. The y value is just k. Yes?
Does the point of inflection run along the y-axis? Or is it not even?
No, it can be anywhere. It can be 2, 4, for example.
Okay. But for example,
For that one,
does it run like along the y-axis? So does it have more than one y-intercept?
there's only one intercept. There's only one y-intercept. There's no more. Yeah, it's just on the y. It's at 0, 0. So that's the only intersection, like for both x-intercept and y-intercept. How? What do you mean by run?
I thought that it would like hit the y-axis and then go up the y-axis.
No. It's only touch once. Like it's just touch once. Yeah, and then it will go somewhere else.
Okay.
Okay, that's the first one. And second one is talk about the direction. Okay, it's very easy for the cube root. There's only 2 directions. There's only 2 directions. The first direction is this direction. And second direction is that direction. The graph is it? Okay, that's better. Okay, just listen carefully here. There's only 2 directions. But like you have a value and k value, right? Don't forget your y equals to a cube root a linear and plus a k value. So we still look at the number in front of x. Well, we have, let's say, we have 2 groups with this same graph. The first one is both positive. Okay, both positive. And second one is both negative. Well, which the negative and positive means the coefficient of x. Coefficient of x and the a value. So the coefficient of x and the a value, which is the number it times in front of the cube root. Okay, in front of the cube root. So if they're both positive or both negative, they just have like the positive shape. And this one, 1 positive, 1 negative. 1 positive, 1 negative. If you have only 1 positive or 1 negative, then that will be the decreasing shape. For example, if you have like negative cube root x plus 1, that will be a negative shape. Okay, that will be a negative shape. Okay, and then number 3 is xy intercept. There must be xy intercepts. Why? Domain and range is R and R. I can take every value, x can be 0. I can take every value, y can be 0. So domain and range is R and R, which means there definitely will be a intercept like somewhere. So we find xy intercept. There's like definitely we can find it. This I didn't say if possible. Like for the previous 3 graphs, I'll say if possible, but like this one is definitely you can find. So you don't need to see the rough shape. You can just directly work it out and label on the graph. Okay, that's it. And domain and range is always R and R. We know that if there's no restrictions for you. Yes?
If there is a restriction, does that mean there still can be x and y intercept? Or
Sorry, if there's a restriction?
can there be different?
No. Like if, for example, if the restriction say your x can only be from 4 onwards, there's no x equals to 0, so you can't find any y-intercept then. So when the question on purpose restricts something for you, which means like everything's unsure, like you can see the whole graph first and then cut the part you need.
Yeah.
Like decide which part I need.
Yeah.
Okay, for this question, first step, I will solve for the point of inflection. So I will make 2x plus 4 equals to 0. X will equals to -2. Point of inflection is -2, -3. Because k value is -3. And second one, select a shape. This is both positive case. So we will have the increasing shape. Because there's a 1 in front of the cube root and there's a 2 in front of the x. They're both positive. They're both positive. Therefore, is an increasing shape. It's an increasing shape. Number 3. When x equals to 0, f0 equals to cube root 4 minus 3. Just a question here. Is that a positive or negative number? You don't need to know how large is that, but it will be negative. Yeah, negative. Can everyone see that? Because cube root 4 is definitely some number 1 point something. It's not going to reach 2. If it's 2, the inside will be 8. So you definitely 1 something. So 1 minus 3 will be a negative number. So just remember that's a negative x-intercept. That's it. What all I need. And when fx equals to 0, 2x plus 4 equals to 3. Now instead of square both sides, you will cube both sides. So 2x plus 4 equals to 27. Okay, same thing but 3 times. So 2x equals to 23. X equals to 23 over 2, so 11.5. So 23 over 2, comma 0. So we have x-intercept. So first we label the stationary point of inflection 0 and -3, which is here. -2, -3, and we have 0 and a negative y-intercept. So about here, that point is 0, cube root 4 minus 3. And we have x-intercept, which is that side. It's quite far this way here, 23 over 2, comma 0. So we can connect those points first. Okay, that's the shape. Like, don't forget that's a point of inflection there. There's a point of inflection there. You need to show like you know there's a point of inflection, like not necessarily be perfect shape, but like you need to see there's the curve. Okay, the curve. And the domain range is just R and R, if you can see it. So if I go vertically, I can touch the graph always. If I go horizontally, I can still always touch the graph. It's just like it's growing very slow, but it still grows that way. Okay, there's no asymptotes. It's not going to stop somewhere. So just keep growing. Okay, that's the first one. Let's have a look at the second one. Okay, second one says fx equals to 1 minus 1 over 2, I will rearrange it. Fx equals to a cube root x minus 1 and then plus 1. It just makes the form looks a little bit better. Well, first step, point of inflection must be 1, 1. Well, x minus 1 equals to 0, give you x equals to 1. Okay, x plus and x minus 1 equals to 0, x equals to 1. And then the k value is 1 as well. So 1, 1 is the point of inflection. Second, x is positive, but a is negative. Must follow a decreasing shape. Okay, so must follow decreasing shape. Number 3 is, say, when x equals to 0, f0 equals to, well, I can write it a little bit to the left. Okay, number 3, when x equals to 0, f0 is 1 minus a half times cube root of negative 1. Okay, 0, x is 0, the inside is negative 1. 1 minus a half times cube root negative 1 is just negative 1. Cube root negative 1 is just negative 1. And that's 1 plus a half, that's 3 over 2. So 0, 3 over 2 will be the y-intercept. So when y equals to 0, 1 equals to a half times cube root x minus 1. So 2 equals to cube root x minus 1. X minus 1 equals to 8. X equals to 9. So 9, 0 will be the x-intercept. The 0.90 is here. 0, 3 over 2 is here. And the point of inflection is 1, 1. Which is here. Okay, this graph is very hard to sketch. Don't forget that's the point of inflection. And this is kind of symmetrical shape. That point is 1, 1. Something similar to that. I know the shape won't be very nice because the scale is stretched too much to that way. But like something similar to that should be fine. But just like the important thing is you show 1, 1 is a stationary point of inflection. Okay, again, domain range is R and R. Alright, I'll give you 10 minutes. You try example 3 and example 4 by yourself. Again, you check also with me on the screen after 10 minutes. Okay, so the third one, after I rearrange it, you can see that they are both negative in front of x and in front of the cube root. Therefore, it should be a positive shape. Your xy intercept should help you to see whether you get a correct graph or not. Okay, it should help you to see whether you get a correct graph or not. So that's the shape of the graph. And we'll solve minus 3x plus 2 equals to 0. I will have x equals to 2 over 3. That's the point of inflection. So 2 over 3 comma 1. That's the point of inflection there. And then I'll solve for y, x equals to 0. Y is 1 minus cube root 2. This is a negative number because cube root 1 is 1. Cube root 2 must be some number greater than 1. Therefore, you have a negative value. 1 minus 1 point something is a minus, but it's a very tiny minus. And then fx equals to 0. I will have 1 equals to the cube root. And we solve for that. We have minus 3x plus 2 equals to 1. Like you cube both sides, you have 1. And then x is minus 1 over minus 3. So that is 1 on 3. So x-intercept will be 1 on 3, comma 0. Well, my graph is like quite to scale, so you should have a shape similar to that. So 2 over 3, 1 is the stage point of inflection, and then a third 0 and 0, 1 minus cube root 2. That's the xy intercept. Again, domain range for cubic function is R and R. Okay, for cube root function is R and R. Okay, 4. fx equals to this. I have rearranged the equation a little bit. I put the cube root into the front, and then I put the minus 4x in the front. Minus 4x plus 2 equals to 0. X will be a half, like minus 4x equals to minus 2, and then x equals to a half. So point of inflection will be a half, comma 3. That's the point of inflection. Because one of that is negative, so I will have a negative shape. Okay, so it's a negative graph. And then we solve for f0. f0 is just 3 plus cube root 2. And then when fx equals to 0, you have 3 plus cube root 2 minus 4x equals to 0. And then that's minus 3. And then you cube both sides, you have a minus 27. Plus the 4x to the other side and plus the 27 to the left hand side, you have 4x equals to 29 and x is 29 over 4. So that's about 7.25. Okay, 4 times 7 is 28, so 7.25. So you have a shape like this. Okay, you have a shape like that. Any questions to those two graphs? Okay, if you don't have any questions, you can work on your homework. Tomorrow I will finish the circle and semicircle. Hopefully I can include some of this example here. Yeah, hopefully I can. Can you like wait? So for the next 25 minutes, can you try example 1 and example 3 for me, please? I'm not going to go through this today. I'll do that tomorrow. But try example 1 and example 3 for me.